Hello everybody and welcome to the second video of the wireless controlled LED on batteries, the explanation video. For those of you that haven't checked the first video, check the first video, which is the demonstration in which I explain really quick how it works and what it does. And in this video I'm gonna go into details of how everything works. Now I'm gonna give it another go right here. So I have this Android app on my phone. I have hostname there. Click enable. The LED powered on. Disable LED. The LED powered off. And here once again 2 AA batteries in series. And just taking the batteries out, and let's talk a bit more about this little guy here. Now this is the ESP 8266 from AI Tinker. It's a Wi-Fi module with microcontroller which can run Arduino code and can run Python as well. I've tested it only with Arduino so far now, and here I solder this small pins to it because you have to solder your own pins. This thing basically connects to my router, to my wireless network, and runs an HTTP server and just turns the LED on and off, so sets the pin high or low based on whatever page you navigate to or whatever link you click. And before I go into the board, the breakout board, I want to talk a bit more about Arduino so that you understand a bit more the concept. Basically Arduino is well, the guys from Arduino built these pretty cool boards here, which are used for programming for hobbyists. So all those robots that you see that move by themselves, or cameras that follow an object, all that crazy stuff is most likely built with an Arduino or a Raspberry, which is something like this but a bit more high level, so to say. Now this thing is using this guy here, this is the brain of it, the Atmel ATmega 328P microprocessor. And now this thing is pretty cheap. It's like $5. This here is like $10. That's for how much I got them. And you can program this thing with the Arduino code, which is very similar to C++. And you can program it to well, basically you control this analog and digital pins. So with the analog pins you can take input like microphone or an analog alarm or all types of sensors that have analog pins. And with the digital pins it's pretty much the same, except that well, the analog pins are more like old school. They work with, well, basically a value. They are 10-bit analog pins, so it's from 0 to 1023. It's basically measuring the voltage. Whatever voltage you give it here, it's it's mapping you that voltage to a number from 0 to 1023, sorry, and 5 volts being the max here for this board. And the digital pins, well, they work similar, but they don't have that many values. They are just on and off, so 1 or 0, that's how they work. So that's pretty much the difference between analog and digital. And this is the Uno board, which is for beginners. If you want to get into programming this little guy here, I strongly suggest you to start with this Arduino board for beginners. If you are a beginner, this doesn't have wireless, but you could add a wireless shield to it, and well, you could there is wireless, there are wireless shields out there. If you search on Google for Arduino shields, you'll be surprised to see how many things you could add to your Arduino board. And like SIM cards, you could make your Arduino board a phone, or a robot, mini robot, or a radio transmitter receiver, or the possibilities are really endless. All those like robotic hands that you see on YouTube, just search on YouTube for Arduino cool projects and you'll be surprised there too. And now, before you program this thing, you need to know some Arduino basics, like how to program in Arduino, and some electronics basics, like what a resistor is, Ohm's law, and really the basics, because you'll need that stuff in order to make out such breakout board. Or you don't really need something like this, you can just use a breadboard, but this is much more convenient after you know all the connections and the schematics. Now, the Arduino Uno is pretty easy to program, meaning that you put a cable here and connect it to your USB through the computer, and you're pretty much set up. Now with this thing, it's a bit harder, because you need here, if we go to esp8266.com, we'll see here's the schematic to program it. So you need an USB to TTL converter. I have right here one, which I'm connecting to my USB port here on my laptop, and I'm connecting this power and ground, and I'm connecting TX, alright, and RX. I just connected them here. And now, if you see right here, it's saying right here prog. This is a button, and reset is a button as well. So that's what these two buttons are here. So in order to program this thing, it's a bit tricky than the Arduino board, the Arduino Uno. Let me show you a simple example. So this is the bare minimum. This is how Arduino code looks. Basically, this is like really the easiest you could go. It's doing nothing. You just have the setup and the loop methods, which are really necessary for it to compile. And right here, if you go to, this is the Arduino IDE once again. If you go to Blink, this is one, like the easiest you could go. The Arduino boards have on the pin 13 they have an LED attached, and you can basically use your Arduino board without anything else, without any external LEDs or any other components. And that's what this code is doing. It's just setting the pin mode to be an output, and flashes the LED every 1 second. And code is very similar to C. Now here is the code that I'm actually running on my ESP module. and here I'm just declaring the variables, and just setting the pin to be an output. I'm initializing the serial, I'm connecting to the wireless with the static IP setup, and handling this event. So when you go to the root of the website, this method is basically activating, and this shows up, this HTML code. Now if you click enable, it's gonna do this thing here, because you're going on the enable page. It's gonna turn the LED on, and for disable it's gonna turn the LED off, and that's pretty much it. Here another method for handle not found, in case you go to a path that is something else than the root or enable and disable, and print something to the serial. Now in order to program it, it's a bit tricky, because when I click here the upload button, right here it's gonna show compile, and it's gonna show uploading and three dots, and when I click upload, like right when I click upload, let's see if I can do it with one hand. Well, I don't think so. When I click upload, I'm gonna need to have the flash button pressed and reset, and when I see uploading here, I'm gonna have to release the reset and keep the flash. So let me just pause it for a second and get back to it. Alright. Let's give it another try. Looks like it didn't want it from the first time. Let's do it like this though. Uploading. And the LED is blinking now. And you can see that the dots are increasing. It's 33% now. So right now it's copying the software from the laptop to the module. And it's gonna be done in now. If I open the serial now and give it a restart, you can see it's connected. So like right when I click reset, it's done, it's connected to the network now. So bam, connected. Not more than 2 seconds, honestly. Now this is what runs on the module itself, and now I'm gonna tell you a bit more about how I managed to make it controllable outside my local area network. And for that, what I've used is the Tomato Shibi firmware, which is a firmware for routers to expand their capabilities. So the regular firmware that comes with your router, installed on your router, the stuff that you log into when you set up your DSL connection or whatever connection you're having, that's the firmware. And this thing is something different. Well, it's the Tomato firmware, and you have to check if Tomato is supported for your router if you want to install it, but it gives you really cool features, like connect to it through SSH, run Python on it, access restriction, see real-time bandwidth, like really cool stuff. If you should definitely check the supported models for the Tomato USB. I'm gonna put a link, and all the source code is gonna be on my website on getyourbuds.com. You'll have a link in the description though, and you'll have the link for supported models as well. If you have one of the latest models of routers, you might not even need to install the Tomato Shibi, because you might already have everything you need to do this stuff that I'm gonna do right now. but usually I still suggest you to install Tomato. So what Tomato gives me, well, what you actually need to control it from outside your wireless network, the first thing is port forwarding, which even if you have an older router or a new router, whatever firmware, you probably have this thing. So don't worry about this, because this is gonna, you have to port forward the port 80 from the device's IP address, so that when you connect to your public IP address on port 80 from your ISP's IP address, you will land on the Wi-Fi device. Now, like I said, this thing is probably on every router out there, almost. But the problem here would be if you have a a dynamic IP address, which I do right here, and that means that in case of power down and power up, or just a router restart for no reason, you're gonna get a new IP address. And that's pretty bad, because if you're out of the country and your router restarts, you won't know your new IP address if it's dynamic. Now, the solution for that is to use dynamic DNS, which is a feature Tomato, the Tomato firmware has, which allows me to select here from all these dynamic DNS services. And I'm using NoIP because I've been using them for a while now, and it's free and does the job for what I'm doing. And you have to set here your NoIP account, email, password, and the host name which you'll set on your NoIP account on noip.com, and just click save, and eventually check this one, force next update, and now you're good to go. Whenever you go to this, you're gonna end up on the device, on the wireless module. And just opening Chrome, and here it is again. Enable, disable, enable, disable. Yep, it's there. Enable, disable. Now, the last thing before I finish is the Android app, which I'm having on my phone here. I've built this Android app in the Android Studio. A really simple app. It's just doing a request to whatever hostname or IP I put right here. And let me actually just show you real quick. So it basically, whatever I put right here, it's adding HTTP in front of it, and either adding enable or disable, and just does a request, and in case of an error, throws the error. If everything goes right, LED enabled, LED disabled. In case of an error, just shows the error, which I'm gonna show you. So once again, testing with it. LED enabled, LED disabled, and if I put here whatever I put, it's not gonna work because the hostname does not exist. Now, like I said, the Android code is pretty simple. This and this, that's all it is. And activity main right here, it's not complicated either. You'll find the source code, which is this code for the Android app, and the Android code and the Arduino code, sorry, on my website on getyourbuds.com. A link will be in the description. I hope you liked it, guys, and let me know any suggestion in the comments below. Thanks for watching and have a nice one.